Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in this video we will understand spectrograms that are crucial in machine learning, deep learning and generative AI because raw audio waveforms are not easy for models to process. A spectrogram transforms sound into a time frequency image, making it possible to apply vision techniques like CNN and transformers. This is why spectrograms power speech recognition, speaker ID, motion detection, and generative models like text to speech and voice cloning. So, without further delay, let us understand what is a spectrogram and how to use it into machine learning, deep learning, and generative AI. So basically, spectrogram is a visual representation of sound, and basically it shows how the frequency content of signal over time. In the last video, I explained you amplitude content of a signal that changes over time. But spectrogram is you can say that map or plot that frequency content of a signal changes over time, and I will also explain why we convert it. So what is the axis of spectrogram? X-axis time in seconds, y-axis frequency in hertz, and color or intensity amplitude of power in dB decibel, and it is basically computed using the short time Fourier transform. So Fourier transform is very important in speech processing, so you must understand both discrete and continuous. Especially discrete is used in speech processing, digital signal processing, and also in speech processing, and it is widely used in speech, music, and audio signal processing. I'm talking about spectrogram. Now let us process into Python. So first of all, load the speech audio file using Librosa.load method, and thereafter we'll compute short time Fourier transform using Librosa.stft. Remember, we will use short time Fourier transform. I will explain why we will use, and that convert amplitude to decibels for a better visualization using Librosa.amplitude to dB. One more, and we will plot the spectrogram with Librosa.display speech show, and this is the code, and now I am going to run it. So let us see here. First of all, I will show you the first program, that there is stop.wave file, and it will convert that audio into time over amplitude. Thereafter second program, the same audio file it will convert into time over frequency. So let us see, and I also explained in the last video, but let us recall it and see that. So here you can see that sample at frequency is 16 Hz and audio length is 1 second, and on x-axis time and on y-axis amplitude, and that would be converted into, just see that second program here, that would be converted into frequency domain. And let us see the plot again. You can see that on x-axis time and on y-axis frequency. Spectrogram speech also, here you can say that the decibel one. So you can see that this is the spectrogram of speech. Now let us understand mathematical explanation of STFT. So basically the speech signal in the time domain is, that is denoted as xt, and the Fourier transform gives frequency, content, but no time information. So here what is we will use, what we will use to preserve time, just we apply a sliding window function w, and see that basically the spectrogram is the squared magnitude of STFT, and that is the spectrogram which would be plotted. This is the final one we have seen. So what is the use of STFT in feature extraction? That means in machine learning. So because this is audio data and we will require to extract features if we are applying machine learning, so we have to extract features, otherwise deep learning will extract it automatically. But we have to understand, so the raw audio signal xt is in the time domain, and STFT that converts the signal into a time frequency representation, that is called spectrogram. And from the spectrogram we can extract important features like energy and power spectrum that measure loudness, pitch and formats, that related to speech characteristics, and MFCC, that is very important, male frequency cepstral coefficient, that is widely used in speech recognition, that is a feature extraction technique from audio data. And these extracted features are then used in machine learning for speech recognition, speaker identification, emotion, and sentiment analysis. So you have understood that how we can use spectrogram in machine learning, deep learning after extracting features. This is why spectrograms power speech recognition, speaker ID, generative models like text to speech and voice cloning. So hope you understood. For more resources, you can visit website www.postnetwork.co, YouTube channel, Facebook page, LinkedIn page, and GitHub repositories. So hope you have understood and you will support me. Thanks for watching the video.